Hello again, and welcome to another fun-filled day in math with Mr. Sims. Today we're going to be learning about parallel lines and transversals, okay? The parallel lines and transversals, basically, as we think about this, we're going to be using the fifth postulate, Euclid's fifth postulate a lot, right? It was the postulate that he tried to avoid using a little bit. It took him a while to actually invoke it. But the reason why is I think when we're looking at this, if we assume that this is true, actually, it limits us to Euclidean geometry, but there's actually geometries where this is not the case, and so that was discovered over time by some people who basically said, hey, well, what if this isn't true? Maybe there's other geometries that exist where that's not true, and so that's how we get some other non-Euclidean geometries. But without going into all of that, what we're going to talk about today is parallel lines and transversals. So I'm going to go ahead and get started. Here we go. Oh, I need another layer. That's fine. Okay, there we go. All right, perfect. Okay, so when you're looking at at the parallel lines and transversals, let's talk about what his postulate actually said. This is his fifth postulate. Okay, it says if a straight line falling on two straight lines make the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which are the angles less than the two right angles. So essentially what he's saying is this: if you have a straight line, let's say this line here, that falls on two other straight lines. Let's call this line U, right? And this line P, right? And this line, we'll call it T for transversal. Why not? Okay, so this is called a transversal, okay? And this transversal is falling on two other straight lines, right? And it says if a straight line falling on two straight lines make the interior angles on the same side, so on the same side of the transversal, if the interior angles are less than two right angles. So what it's saying here is it's saying, okay, let's say this is a 90-degree angle. Let's just say it is. If this one here is anything less than 90 degrees, if it's less than 90 degrees, right, then this two straight lines, if produced indefinitely, in other words, if you stretch out these straight lines to infinity, that they will meet on the side in which the angles are less than two right angles. So what it's saying is, since these two are less than two right angles, that eventually, if I keep stretching these lines out here, that they will eventually meet together. And we could actually see that if we wanted. Obviously this is not going to be perfect, right? But essentially you could, whoa, didn't want to do that. No. So let's go, and if I just keep stretching out, you can see they're getting closer and closer, and sure enough, if I keep going, eventually they're going to touch somewhere around there. Okay, so you can see how they basically work out to touch eventually, right? And what he's saying is that it's always going to happen on the side that has the two angles that are less than 180 when you put them together. Okay, so 90 plus anything less than 90 is going to make those lines converge on this side, right? So he's saying it's not going to be on the side where this number is 90 and this one's greater than 90, right? If this side is less than 90, this one would have to be greater than 90. So it's not going to converge on this side. Instead those two lines are going to converge on this side. All right. So basically that's what that's saying. Okay. Now you're probably wondering, well, what does that have to do with parallel lines? And actually, he didn't mean it to talk necessarily directly about parallel lines. He's actually just talking about just the nature of lines and the way they stretch out, right? Here in this case here, you can see that this one's clearly less than 90 and that this one here is clearly less than 90, right? So as you can see, they're going to converge on this side. Notice that they are on different sides of of the transversal this time, and on this side, on this one, they were on this side, right? On this one, they were on this side. So it doesn't matter which side, as long as when you add these two together, if they're less than 180, right? Because that's less than two right angles. Two right angles would be 98 plus 90, which is 180. So if it's less than the 90 plus 90, right? If it's less than 180, these together, then it's going to converge on this side, right? And basically, if you're looking at that, then you might have the question, well, what if they are equal to the 90, the two right angles, right? So in this case here, you have 90 degrees and you have 90 degrees. And if in fact they're absolutely equal to two right angles, right? 90 plus 90 is 180, right? If you add these two together, they're 180. So because it's equal, their sum is equal to 180, a special thing happens. We end up with a parallel line. So this line here is parallel to this line, and they're never going to touch as long as it's in a two-dimensional space, right? As long as it's in two-dimensional space with the regular Euclidean geometry, these lines will never touch. And so this is it's a super helpful concept then, right? Because this is what naturally follows from his postulate, right? So what we're going to do now is we can look at this slightly different. We can say, okay, well, what if they're not both 90, but what if those measurements still add up to 180, right? So for instance, on this side here, let's say I have 120 is this angle, right? And this angle that's still on the same side of the transversal, right? That's interior to interior means that on the inside of these two lines, right? If this one here were say 60, right? Well, 120 plus 60, right, is equal to the 180, or to put it a different way, is equal to the two right triangles that he mentioned here, right? He said falling on two straight lines make the interior angles on the same side less than two right angles. Well, in this case, we're saying that if they are in fact two right angles equal to two right angles exactly, that is going to make the lines parallel. Okay, so this is basically the case that we're seeing. Okay, what we're seeing basically is this. I don't, what up, Mr. Sims? I'm sorry, this one should be the 61, Mr. Sims. That just didn't even look right. 60, and this is the 120. I'm sorry about that. There we go. So 60 and 120. Okay, and the math still works. Okay. So basically what we have here is we have that these lines are parallel, but the reason why they're parallel is these two interior same side angles add up to 180. And so you can see that that will always be the case if you're in two-dimensional Euclidean space, that that if you have the 60 and the 120, that these lines here will be parallel, okay? So a couple cool things happen if that is the case. What happens is this. You basically have your regular lines, right? These two now we know are parallel. And a cool thing happens when you have parallel lines cut by a transversal. There's a whole bunch of angles that end up being congruent to one another, right? So in order to understand it and be able to indicate these angles, I'm going to go through some terminology real quick with you, okay? So interior, if I say interior, what I mean is it's the inside angle. So these would be interior angles. Anything that's inside of these two lines here would be interior angles, all right? And I'm just going to actually erase some stuff here just to make it so that we can draw stuff a little bit easier and not get confused, okay? So once again, anything in basically in this region here, right? Not including this one here, all right? So once again, this region like right here, right? So either this angle, this angle, this angle, or this angle. Those are all interior angles, okay? Those are all interior angles. Okay, exterior angles, on the other hand, are the angles that are going to be on the other side, right? They're going to be on this side of the parallel lines, right? So this would be an exterior angle, right? This would be an exterior angle, this angle here, and this angle here would be exterior. So those are all exterior angles, right? So once again, that was this one. This one's an exterior angle, right? This is an exterior angle here, right? And finally, this one right here. Oh, sorry. This, whoa, not that one. What on earth was that? I didn't even know I could do that. Cool. And that's another exterior angle, okay? So basically, those are my exterior angles. So once again, interior on the inside of the parallel lines, exterior on the outside of the parallel lines. Alternate. Alternate means if I have one on this side of the transversal, that I have one on the other side of the transversal, okay? This is my transversal. I'm going to call this one L, right? Why not just L? We'll call this one M. All right, so the transversal, if they're on opposite sides of the transversal, right, then that's called alternate, okay? So that would be alternate. All right, let's go on to the next one. The next one is consecutive. So consecutive means it's the next one that follows. So if this was angle like 1 and this was angle 2, well, they would be consecutive because this one comes right after that one, right? So that would be a consecutive interior angle in that case because they're on the interior and it's just the next one on the interior. That's on the same side of the transversal. Very important, okay? Consecutive exterior, right, would be like this one here. Maybe if that was 1 and this was 2, then 1 and 2 would be consecutive exterior angles, okay? Because they're exterior because they're on the outsides of the parallel lines, right? But they're consecutive because it's the next one from this one that's on the exterior, okay? Makes sense? Very similar, by the way, to same side, right? You could call these same side exterior angles, right? If this was 3 and this was 4, 3 and 4 would be same side interior angles, right? But they'd also be consecutive interior angles. A lot of times those two will be the same. So anyways, you have, so once again, interior inside the parallel lines, exterior outside the parallel lines, alternate on opposite sides of the parallel lines, consecutive meaning one and then the next one that's on the same side of the transversal, that's the same thing. And then finally, same side just meaning on the same side of the transversal. Okay, so I'm hoping that that just clarifies some of the terminology. So let's go ahead and label some points real quick. There's another piece of terminology that I want to introduce as well. 7 and 8, okay. So if these were all my angles, a really cool thing happens once you have a transversal cutting two parallel lines. Whatever whatever angle 1 is, right? Because it's a vertical pair with angle 4, it's going to be congruent. But there's also another cool thing that happens. When you have a two parallel lines cut by transversal, not only is 1 equivalent to 4 or congruent to 4, right? But 4 is also congruent to this one, 5. In other words, alternate interior angles are congruent, all right? And once again, this 5, because it's a vertical pair with 8, is also going to be congruent. So 1, 4, 5, and 8 are all congruent. So you could actually make a lot of reasonings here. Basically that 1 and 8, right, those are alternate exterior angles, right? So when you have two parallel lines cut by transversal, then the alternate, let me actually just type these out. I think that'd be a little bit better. So alternate exterior angles are congruent. All right. Also, by the way, like 4 and 5, right? 4 and 5 are alternate interior angles are congruent, right? All right. So hopefully that makes sense, right? Let's keep going. Not only is that true, but you'll also notice if 1, right? If you have 1 and that 1 is equal to 4, right? Well, if you think about it, this whole distance here, because it's a straight line, has to be 180 in total, right? So 2 has to be whatever 180 is minus angle 1, right? So it's going to be some amount. But also, since 1 was equal to 4, then 4 is going to be that 4 then is also going to be the same as 1. So when I take 180, because this is also 180 here, and I subtract it by 4, I'm going to get this amount that's 3. Well, you're going to notice that 3 is going to be the same amount as 2, right? And you'll also know it's the same because they're also vertical pairs, right? So we now have that 2 is congruent to 3 as well, right? And sorry, I'm just clearing off some stuff so we can see it more clearly. So 2 is congruent to 3 as well, right? So what you have now is you have these sorry, my brain just stopped there. So you have also, once again, alternate interior angles are congruent, right? But these would be the other pair of alternate interior angles are congruent, right? And you also have this, though, 7, right? And you're going to see some other similarities here. There's another similarity that we have. Let's go over to here, and I'll write what that is. So with this similarity here, you also have what's called corresponding. So corresponding angles are congruent. And corresponding angles, what that means is this. Imagine for a second that you took this x here, right? If you took this x right here, and you were to take that x and just move it over on top of this x, right? The angles that match up, right? 2 would match up with 6, 1 would match up with 5, 4 would match up with 8, and 3 would match up with 7. Those are the corresponding angles, right? You can also think of it like a clock, right? If it's in the same clock position, right? These 2 would be in the same clock position, therefore they're corresponding angles, right? So in this case, corresponding angles 2 and 6 would be congruent, right? So angle 2 would be congruent, right? Congruent to angle 6, right? You also have that angle 3, right, would be congruent to angle 7 once again because they're corresponding angles, right? And likewise, you'd have angle 5 is congruent to angle 1. All the corresponding angles are going to be congruent to one another because you have two parallel lines cut by transversal. Very important that they are two parallel lines cut by transversal. This does not work if they're not parallel, okay? So anyway, alternate exteriors are congruent, alternate interior angles are congruent, corresponding angles are congruent. All right, so hopefully this has made sense so far. What else I can say? Oh yes, so if you have interior same side angles, right? Same side interior angles, right? Same side interior angles, or consecutive interior angles is another way you could say it. Same side interior angles are not congruent, but they're supplementary. Okay, supplementary because they add up to 180. Okay, they add up to 180. And the reason they add up to 180 is basically it boils down from the beginning here where we had that 1, right? If 2 is supplementary to 1, and this is a vertical pair here, right? Right? And then we also know that 5 is supplementary to 1, and that this would be the vertical, the supplementary angle to 5 then, right? Then these two here, if 3 and 6 are congruent, right, then 5 and 3, if 5 is supplementary to 6 and 6 is congruent to 3, well, then you're going to have that, that these two are also supplementary to one another, right? Because obviously if 6 is the same as 3, then it would follow that whatever amount you need to add to 6 to get 180 would be the same amount that you need to add to 3 to get 180, okay? So there you have your alternate exterior angles are congruent, alternate interior angles are congruent, corresponding angles are congruent, same side interior angles are supplementary. So what that also means, though, is this. Let's say you don't know that these are parallel lines, right? What that means is that if I should come upon a line, two lines, and I see that this angle is congruent to this angle, well, that tells me, hey, these two lines must in fact be parallel, right? And once again, if this angle were congruent to that angle, right, or any of these angle relationships that we just said, right, if we notice that congruency happening, then we know that those two are parallel. All right, so without belaboring that point anymore, if that didn't make sense to you, I suggest maybe going back and looking at it one more time. But we're going to go ahead and do some problems here that utilize some of this information, okay? So this one says solve for x, right? 11x plus 10 and 6x here. So this angle here is 11x plus 10. This angle here is 6x. Now, we know that those aren't the same. Obviously, you can see they're not the same, right? But we also know that these are parallel, right? Since these two lines are parallel, and these two angles here are same side interior angles, we know that same side interior angles are, same side interior angles are what? Supplementary, right? So we can go over to here, and we can set these equal to something. 11x plus 10. To be supplementary means that when I add these two together, that should be a plus sign. It's connecting them. So when I add these two together, I should get 180, right? Because they're supplementary. So now it's just a matter to solve for x. I just am going to take and simplify, right? I get 17x plus 10 is equal to 180. I'm going to subtract 10 from both sides. So I get 17x is equal to 170. Divide both by sides by 70, and I get 17, and I get the x is equal to 10. So my answer should be x is equal to 10. All right, moving on to another one. I think you probably understand that concept. Well, you know what? Let's do one where it's not there. So this one here, you have x plus 53, right? So these sides here, these two angles here, right, would be corresponding, right? If you think of it like a clock face, right? These two would be on the same part of the clock face, right? So as we know, corresponding angles, if these are if these are parallel, these two lines, then the corresponding angles are also congruent. So what that means is I can set them equal to one another. 50 is equal to x plus 53. I subtract 53 from both sides. And I should get that x is equal to negative 3. All right? And that right there should be my answer if I did the math right. I think I did the math right. All right, this one here. Find the measure of the angle indicated in bold. So this one here, they want us to find the measurement of this angle right here. And you'll notice that this angle is across from this one here, right? And so this is called a vertical pair. So remember, with a vertical pair, they're congruent, they're equal. So I can set them equal to one another. Negative 6 plus 6x, right? I can subtract 5x from both sides. When I do that, I get that negative 6 plus x, right? Plus x is equal to 5. So then I add 6 to both sides. Add 6. Add 6. And I should get that 11 is equal to x. All right? So 11 is equal to x. Okay. So hopefully this is starting to make sense. Now, once again, 11 equal to x is not actually the right answer for this because they want me to find the angle in bold. So I now need to plug that in for x here. So my answer ends up being negative 6 plus 6 times 11, right? Which is what? It'd be 66 plus a negative 6, right? Which, as you know, would be 60. So my answer, my real answer, is this one right here, okay? 60. Not this. Not this, all right? Sorry about the chicken scratch. All right, let's go ahead and do something a little bit harder. I think we got that, right? Find the measure of the angle indicated in bold. I think we can figure that out now. Here we go. This one here, find the measure of the indicated angle that makes lines U and V parallel. So this is actually asking us a slightly different thing. This is saying, okay, we're not going to assume they're parallel, but let's say we wanted to make them parallel. Let's say that we had lasers that we were shooting out this way, pew, and this way, pew, and we wanted them to be parallel ultimately. What angle would I have to make this to make that a true scenario where they would never touch, they would go on forever and never converge? And the answer is it would have to be 46 degrees, assuming, two-dimensional space, right? That it would have to be 46 degrees because, once again, right, corresponding angles, if these two lines are parallel, then the corresponding angles, if they're parallel and cut by transversal, then the corresponding angles are congruent. So 46 would have to be congruent with 46, right? Let's do this one here. Find the measure of the indicated angle that makes this one parallel, U and V. So here's line U, here's line V. Once again, right, this would be another example of corresponding angles, right? Ignore this other transversal here. It's not important for us in this case, right? I don't need to pay any attention to that. Don't mistake those for congruency marks, right? But this angle here would have to be congruent to that if we wanted these to be parallel, right? Because, once again, corresponding angles are congruent. So this would have to be 73. All right, find the value of x that makes lines U and V parallel. So now it's going to be slightly harder because they're not just talking about an angle now. They're talking about making it so that that the x value would make this true, right? So if I look at this one here, if I looked at this angle here and this angle here, right? These are same side interior angles, and as we said earlier, same side interior angles or consecutive interior angles are supplementary. So what that tells us is that together those have to add up to equal 180. So what I'm going to do is I'm just going to come over here, 9x plus 9, and I'm going to add to that the 26x minus 4, and I'm going to set that equal to 180. Right? And in doing that, I can now just simplify, right? 9 plus 26 is going to be 35x plus 5. 9 minus 4 is the plus 5, right? Is equal to 180. All right, then I'm going to subtract 5 from both sides. When I do that, I should get that 35x is equal to 175, right? Alexa, what is 175 divided by 35?
175 divided by 35 is 5.
So x, yes, you did. So,
Thanks for your feedback.
so x is equal to 5, right? So the value of x that's going to make that possible is 5. Now, if I want to actually find the angle values, by the way, that makes that possible, then I could plug 5 into those and see the angles that make that possible. But I'm not going to do that right now. All right, I trust that you could do that if you wanted to. Okay, here we go. Let's go ahead and do one more. Oh, I like this one. Let's do this one here. Let's do two more actually. Okay, so this one here is these are uh, sorry, my brain just stopped on me. These are alternate exterior angles, right? And as we know about alternate exterior angles, we know that alternate exterior angles are what? Congruent. So this side has to equal that side, right? So that's going to make 9x plus 1 equal to 8x, sorry, 8x plus 12, right? Now I'm just going to take and subtract. That shouldn't look like a 4. It's not a 4. Grumble. Plus 12. All right, so I'm going to subtract 8x from both sides, right? I subtract 8x, subtract 8x, and I get what? I get that x plus 1 is equal to 12. Then I'm going to subtract 1, and I get that x equal to 11. So the value of x that makes it so that these two are parallel is 11. Now I want to stress to you that is not the angle measurement. The angle measurement, if I wanted to find that out, I'd have to plug it in. That'd be 88 plus 12, 88, 98, that'd be 100. So this would be 100, right? So if these both were 100, then I would know that once again UV are parallel. Line U and line V are parallel, right? So anyway, I hope that makes sense. Let's do one very last one. This is a lot like the last one, right? The only difference is we know that these are going to be congruent, and we know that this one's 90. So basically, I can set 90 is equal to x plus 97. I can subtract 97 from both sides, right? So that's going to give me that x has to equal -7, okay? So x equals -7. So anyway, as you can see, basically it's all very similar things where what you're trying to do is just make it so that it fits one of these rules where the alternate exteriors are angles are congruent, or the alternate interior angles are congruent, or corresponding angles are congruent, or same side interior angles are supplementary. And if you can get one of these pictures to follow that rule, right, by making an x a certain value, then these lines are going to end up parallel. And that's really helpful for us in real life because, like, let's say we were doing something and we could measure the angles, right? But we could get an idea if we really have something parallel, right? Anyway, I think that that basically is enough of an explanation for that. I think that you're starting to get it. I do want to stress to you once again, when you're looking at say exterior angles, like if I were to get rid of all these angles here, I want to stress to you that basically because these are all these are congruent, you're going to end up with only really two two angles, right? So let's say this was 120 and this was 120, right? This would also be 120 and 120, and then this would be 60, and this would be 60, 60, and 60, right? And all of those would basically, I mean, there's basically only really two different angle measurements, even though there's 8 different angles there. There's really either 120 or 60 here. So it really does greatly simplify it if you know that these are parallel. All right. So anyway, once again, we started off with the parallel postulate. We talked about, what his parallel postulate was really stating, and he was actually talking really specifically about the converging of two straight lines, right, that were cut by a transversal, and saying that they would converge on the side that both of them are less than a total of 180 degrees, right? When you add them together, that they would converge on this side. This one is less than 180 on this side, so it's going to converge on this side, right, of the interior. For looking at those interior angles. And then we said, oh, well, what if this is a situation where those interior angles on the same side are exactly 180? If they're exactly equal to 180 when you add them together, and that gives us the issue where they're the situation where they're parallel lines, right? So then we looked at those parallel lines and we said, well, let's examine some of these angles. And we saw that basically, although you have 8 angles, really it boils down to really two angles, whether it's 120 and 60, or let's say this was 130, then this would be 70, no, sorry, 50, right? If this was a 170, then this one over here would be 10, right? But basically, whatever this angle is going to be the same as it, this one and this one, that those angles are going to be congruent, and that those angles are going to be congruent, right? We talked about the various angles that are congruent based on that, right? We came up with some basic rules for you to remember, right, to help you out. And then we did some practice problems where basically it's a matter of solving for x based on knowing that those are parallel. And then we moved on to say, well, what if we wanted to make them parallel, but we didn't know they were parallel, but we want to make sure that they are parallel? What would this value have to be? And we figured out what the value would have to be. Then we made it slightly more algebraic by adding some unknown variables there to just make it a little bit harder for us. Well, I hope that that made sense to you. I hope it worked out. I wish you the very best. Keep up the great work. I'm proud of you for getting the help you need. And I look forward to just seeing what you're capable of in the future. Have a wonderful, wonderful, wonderful day. And I'll talk to you soon.